2.1, which is the first section in chapter 2, and the title of the section is parallel lines. And so I know that you've probably heard about parallel lines before or seen them. And when I ask students what are parallel lines, normally they'll say something like, well, they're lines that never cross or never intersect, and you're correct. And so now we're going to add another layer on top of that and talk about the relationships in parallel lines when we put another line in between them called a transversal. So we'll get there. But anyway, essentially what we're going to do is look at what happens when we cut parallel lines by a transversal in terms of the angles that are created by that. But before we can do any of that, we do need to review a couple vocabulary words. I'm sure a lot of you realize that if you don't know the vocab, you're not going to do well. So let's review a few things. Vertical angles, first of all, are angles by rays. They're directly across from each other. They are not adjacent. I know some of you remember that from your test. So they're directly across from each other, but more importantly, they are formed by two pairs of opposite rays. So that's important for this. Linear pairs are two adjacent angles, right? So there's the adjacent part. Adjacent angles most of you got this part okay on the test. If they're a linear pair, they form a line, which means that their angles add together to be 180 degrees. Okay. And the last one, adjacent angles. I figured this one would be easy, but apparently some of us still need a little bit of review on it. Adjacent angles are angles share next to. So adjacent angles are angles that are just next to each other. All right. Like are always next to each other. So not all angles are adjacent. Some angles are not going to be next to each other. In that case, they're not adjacent angles. Um, so anyway, that's the vocab that you should have gained from chapter 1 to make you successful here in chapter 2. Chapter 2 is about. So we've got a new vocab word. It's called a transversal, and we're going to be using this for the rest of geometry. And a transversal is a line is that if I have two lines, we'll make them parallel here, okay? I'm going to cut it, and that's called the transversal, okay? So we'll denote it with T or some other letter. But it intersects two or more lines at distinct points. So here's one point, here's another point. Distinct just means different and not alike. That's the easiest way. Chapter 2 is all about parallel lines that are being cut by this transversal line. To say transversal line, we just say transversal. Okay. More vocab. And if you don't understand this vocab, you will not do well. So for those of you that make flashcards, this would be a good thing to make flashcards about. Okay, corresponding angles. These are angles that lie on the same side. So there's that word again. positions. Corresponding just means the same, okay? Positions. Picture. So we are on the same side of the transversal line. So that means we're either all, oh, that's not a pen. That means we're either all over here or all over here. Okay, that's the same side of the transversal line. That's what that part means. And in corresponding positions means in the same position relative to the parallel line. So my examples here, okay, and I'm going to do this in different colors so that our picture is very colorful in the end. We'll do this one in yellow. Examples are like 5 and 1. Notice they're on the same side of the transversal and both on top of the parallel lines. So we could say angle 5 and angle 1. Say 7 and 3. Oh, I forgot the angle sign. You could also say 6 and 2 or 8 and 4. Okay, all of those are transversals, or excuse me, all of those are corresponding angles. And angle 2, and then the other one was angle 8 and angle 4. Alternate exterior angles, and the words here give a pretty good clue as to what they are. These are non-adjacent, which means on the outside, angles on alternate part that lie on opposite sides that are on the outside of the line, the parallel lines, and opposite sides of the transversals. So outside means that we're 5 and 8 or 2 and 3, and opposite sides means that we're on opposite sides. So we could say 5 and 3. Alternate exterior angles. So an angle 3. Say angle 2 and angle 8. Example. Angle 2 and angle 5 are not alternate exterior angles. You have to pair them with the correct pair, like the correct angle. So like 3 and 5 are alternate exterior, and 2 and 8 are alternate exterior, but you can't say 2 and 3 are alternate exterior. Okay, it comes in a pair, so be careful with that. Interior angles are exactly the opposite of what we just did, except for they are still non-adjacent. Interior on transversal. But now we're on the inside. If we look here, alternate interior angles would be like 6 and 4 or 1 and 7. They're on the inside and opposite sides of the transversal. 6 and 4 and then 1 and 7. Same side interior angles. So these are exactly what they say they are. They lie on the same side of the transversal. The inside of the parallel lines, exterior means on the outside of them. Examples I'll do in green here. Interior might be like 7 4 or 6 and 1. 4. And 4 and 6 and 1. That means important for those you non-English folk. Very important and imperative that you understand these vocab words. Make flashcards, study them, sleep with them on your pillow. I don't care. But if you don't understand these vocab words on this page, it's going to be very tough for you to succeed. Okay, so that's my hint, hint, wink, wink for you. Talk about some new theorems. We might prove some of them. We might not prove any of them. But here's some new theorems for you. So the first one is the same side interior angles postulate. So there are these vocab words. Again, I told you if you didn't understand them, it would be a problem. Here's what this theorem says. If a transversal intersects two parallel lines, same side There's another vocab word. If you don't know your vocab, that's a problem. Supplementary means adds up to 180. So here's what this means in a picture. If you have two parallel lines, and we show that these lines are parallel, you guys, by little tick marks that look like little arrows. So that if you see that notation, that means parallel, okay? And we're going to cut these parallel lines with a transversal. Okay, I'm going to label it T. That we have, we'll call this angle 1 and that angle 2. As you notice, those are same side interior angles. So if you've got this situation, then the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Interior angles theorem. So if you've got a transversal, parallel lines, sure. If we have two parallel lines, and I'll draw those little arrows to indicate that they're cut by a transversal, and now we have alternate interior angles. So maybe it's 1 and 2 like that. Equals the measure of angle 2. Or really, because they're congruent, what we would say is angle 1 is congruent to angle 2. But either alternate exterior angles theorem says if a transversal intersects two parallel lines, then alternate angles here is let's say if we have two parallel lines here cut by transversal, this time we have alternate exterior angles. So maybe angle 1's right there and angle 2's right there. Then what we can say is angle 1 is congruent to angle 2. The corresponding angles theorem says if a transversal intersects two parallel lines, then corresponding picture. It's a theme here. Cut by a transversal. T. Corresponding angles. So maybe it's angle 1 and angle 2 like that. Now keep in mind there are more corresponding angles than that, right? So like let's say that this was angle 3, and that's angle 4. That means angle 3 and angle 4 are also congruent. Okay. On. Any corresponding angles fits this. And similarly with all these other definitions and theorems that I just did, any alternate exterior angles are congruent. Any alternate interior angles are congruent. And any same side interior angles are supplementary. Okay. Generalize out to all of that. So we're going to prove the alternate interior angles theorem. All right. We just stated this theorem that alternate interior angles are congruent. So now let's prove it. All right. I'm going to do a 2-column proof here. And if you've come up with a different way to do this too, then that's fine as well. But we're given that M is perpendicular. Parallel. That right there means parallel. That's just shorthand notation. M is parallel to N. And if you know, those are just 2 lines. Okay. So that's, and similarly, we're also given that angle 1 and angle 2 are supplementary. Angle 1 and angle 3. My bad. Angle 1 and angle 3 are supplementary. Given that M and N are parallel, we can't really do anything with that, right? We can't go anywhere with that, but we can go somewhere with that second statement. So if angle 1 and angle 3 are supplementary, that means the measure of angle 1 plus the measure of angle 3 equals 180 degrees. And the reason is because the definition of supplementary angles. That. Okay, well, if 1 and 3 add up to be 180 degrees, oh, because we haven't used angle 2 yet, and angle 2 is there for a reason, and at the end we got to say something about angle 2 anyway. So we could also say that the measure of angle 2 plus the measure of angle 3 equals 180 degrees, and this time we can use the linear pairs theorem. See, well, if they're both equal to 180, well, then they have to be equal to each other. So the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. And that, my dear friends, is the transitive property. If both sides have the measure of angle 3, then we can subtract the measure of angle 3 from both sides, and we're left with the measure of angle 1 equals the measure of angle 2, and that's a subtraction property. Write the correct notation. Angle 1 is congruent to angle 2, and that's of congruence. Rather quickly, but that's just so this video doesn't end up being 7 years long. So if you have a question about that, just let me know. But that's the proof of the alternate interior angles theorem. You could create a similar proof for all of those theorems. So if you want extra practice, there's some extra practice for you. Prove those theorems, and I can always check your work. Example. So the parallel lines are intersected by a transversal as seen in the picture. Find the measures of the other angles if the measure of angle 7 is 52. Okay, so step 1 is draw a picture. Done. Okay, step 2 is label your picture. All right, measure of angle 7 is 52 degrees. All right. Find everything else. So what I like to do is I just like to start making a list. Okay, I need the measure of angle 1. I need the measure of angle 2. I need the measure of angle 3. I need 4. I need the measure of angle 5. I need the measure of angle 6. And I need you're like, oh my gosh, this is so much work. Not really, okay? So let's use some theorems that we know. All right, we know the vertical angles theorem. That's one from last chapter. So the vertical angle theorem says that 7 and 6 are congruent. So right away we can say, well, measure of angle 6 is 52 degrees. Look at angle 6 and angle 3. Those are alternate interior angles. Well, you just proved that alternate interior angles are congruent. So that means that measure of angle 3 is 52 degrees. The vertical angles theorem to say, well, then that must be the measure of angle 2 as well. You could do to find the rest of them. You could notice that 7 and 8 are a linear pair, right? Or you can use the same side interior angles being supplementary to understand, because all of these are 52, right? So angles are supplementary, so you'd still do 180 minus 52. Regardless, no matter which way you look at it, you're going to end up coming up with 180 minus 52. And 180 minus 52 equals 128. So if you started with angle 8, that means angle 8 is 128 degrees. And then vertical angle theorem says, well, then 5 must also be 128 degrees. And then alternate interior angle says, well, then 4 must be 128 degrees. And then we vertical angle theorem says that must be 128 degrees. Something else you'll notice. Alternate exterior angles are congruent, which works. Usually there's more than one way here to check your work. So as you can see, it was just kind of a waterfall effect. You got one thing and then you got the other relatively quickly, hopefully. Okay. Vocab, that one might have been difficult. One we're going to do in class. So that's how we're going to start Friday, or do in class part of Friday, is we're going to do this one in class. If you would like to attempt it beforehand, that would be good practice for you. But it is rather, it's not a super straightforward proof, so that's why I want to do it in class together. But if you're feeling up to the challenge, you can attempt it beforehand, and then you can check your work when we get to class. And similarly with this last one, okay, it looks scary. It's not, guys. It's really not. So I want you to attempt this on your own, okay? And I'm going to give you the answers. I'm going to give you straightforward the answers. I'm not going to show the work on how I got there, but I'm going to tell you that the answers are the measure of angle 1 is 112 degrees, and the measure of angle 3 is 68 degrees. You to figure out how to get there. I want you to do the problem, but there's the answer so that you can check them. And then if you need help getting there, please come see me. Okay? So you should have everything completed besides page 5 at this point. And that's what we'll do in class. I encourage you to study this tonight and come to class with questions on Friday. All right?